Come along.
Right. We're going to carry on with trig equations, and we're doing from your textbook exercise 4.8, page 156. So if you pick it out, please, and you should have your notes with you. The first part of the question says it's an identity which says show that sine 2x over cos 2x minus 1 is equal to negative cos x over sine x. So split up your page. And let's have some decent human beings who support Liverpool. So we'll have Hannah and Tatiana doing this. Hannah, sine 2x, yes, and obviously they're going to get it right because they're Liverpool supporters. Will become 2 sine x cos x. Okay, right, and then cos 2x minus 1. Now cos 2x, you've got a choice of 3, but look at the right hand side. At the bottom on the right hand side is sine x. So I would keep that as sine, which is obviously what Tatiana said, and she said yes, go make that 1 minus 2 sine squared x. Okay, so that's that, minus 1. And neaten that up a bit, so it becomes 2 sine x cos x 1 minus 1, and it smashes that, minus 2 sine squared x, and the 2's will cancel out, that 2 will cancel with that 2, and the 1 sine will cancel with that, so you'll be left with negative cos x, and you'll still have a sine x at the bottom. And what do you know, our Liverpool supporters have got it right again and shown us that the left hand side is equal to right hand side. Ah, lovely, lovely, lovely. Okay, so this is page 1. Okay, let's have some hockey girls doing this, some Hannah and Boati, if you'd be so kind. Right, so B2 says hence, so it's using your answer from B1, and in B1 we proved this. And remember, even if you couldn't do that in B1, use it to do B2. So we know that. Okay. Sine 2x over cos 2x minus 1 is negative cos x over sine x. Then it says, hence, solve for x. Okay, if sine 2x over cos 2x minus 1 is equal to 1, right? Okay, and x lies between 0 and 360. So, if they say hence, you've got to use this answer. Well, it's definitely going to make your life a lot easier. So you're going to change that into that. So if that's equal to 1, it must mean that therefore negative cos x over sine x is equal to 1. And therefore times by sine x, negative cos x is equal to sine x. The angles are the same size, and they're sine and cos, and there's a single term. You can divide by what, Hannah? Yes, you can divide by cos. Well done. So you'll get negative 1 is equal to tan x. And Boati's saying, oh, I don't need a calculator for that. It's pretty obvious. The rest of the riff-raffs can do that. I will just say if tan x is equal to negative 1, x must be equal to negative 45 plus k180. Remember the red school, and you get k is an element of z. Okay, so there's your general solution, but they want the answers between 0 and 360. So what will give us the answers between 0 and 360, Hannah? Well, negative 45 won't work, but if I add 180 to negative 45, I'll get x is equal to negative 45 plus 180 is 135 degrees. If I add another 180, it's going to be, what's that? 235 plus 18, 315, I think. Let me double check on my sneaky notes. Yes, it is 350 degrees, and there is your solution set. And that is your answer. Hannah and Boati, you've done the hockey team proud. Well done. Okay, humans. Now first, let's have a look at C2. It says solve for beta is an element of minus 180 to 270 degrees, given that cos 2 beta sine beta minus cos beta sine 2 beta is equal to negative 0.5. Now, when I first did the sum, I used double angle formulas, and I got it right. But there's an easier way to do it. I just thought about that now, and that is to use a compound angle formula. So the pattern you've got is you've got cos of an angle in the one term and sine of that angle in the other term, and sine of an angle and cos of the same size angle. So that opens up the possibility of using double angle formulas. Now you've got a formula, if you look on your formula sheet, which says if I've got sine of A minus B, it's equal to sine A cos B minus cos A sine B. And now with the sine rule, it's quite important, okay, because whatever angles with the sine goes first in the first term, and that's quite important. So if you want, just rearrange this bit over here, so to put the sine in front, so it'll become sine, where are we? Sine, I'm just swapping them around because they're multiplication, so you can. Sine beta cos 2 beta minus cos beta sine 2 beta. So now if you look at your patterns, you've got this pattern over here, that over there, sine of an angle, cos of an angle, minus cos of the same angle there, beta and beta, sine of the same angle over there. So how can I rewrite that? Well, it's going to become, Merveille, let's have you, what's it going to be? It's going to be sine of, or what goes with sine in the beginning? It's beta. So it's sine of beta minus the next angle, which is 2 beta. Sorry, I've been a dumbass. I should have been writing here, this is equal to negative 0,5. So now I've got, therefore, sine beta minus 2 beta is equal to negative 0,5. Well done, Merveille. And a chicken minus 2 chickens is negative a chicken, so I get sine of negative beta is equal to negative 0,5. And you can go solve for negative beta and you'll get the right answer, or you can just, sine of a negative angle is negative sine beta is equal to negative 0,5. So sine beta is equal to 0,5. So then use a calculator or special angles. Beta, remember there's always going to be 2 solutions for sine, don't forget that, it's a big mistake a lot of you make. So Merveille, what's it going to be? We're going to have beta is equal to 30 degrees, good girl, plus K 360, and for sine, it's, remember it's where it's sine positive, there and there, and in quadrant 2 it's 180 minus, so, or you can say beta is equal to 180 minus 30 degrees plus K 360. Somewhere we should mention K's. K is an element of integers. So the one solution set is that. The other solution set is beta is equal to 150 plus K 360. Merveille, you know, it's just so impressive what you are doing here. And yes, I know, I haven't finished. Because they only want the answers between minus 180 and 270. Okay, personally I don't give a rat's ass if you don't have them in the right order, as long as you list them. Okay, so from this solution set, well, 30 falls in the required interval. It'll be the only one, because if you minus 360 it's going to be too small, and if you add 360 it's too big. And from this solution set, 150 is going to be the only one that works. So your solutions, the final answer is beta is 30 or beta is 150. They are amazing. That was page, I think it was page 3. Okay. Good day. Right. To do this next lovely sum. Okay, we're doing question E of 4.8, and the question says solve for theta if sine theta plus 60 degrees is equal to 2 sine theta, and they want the solutions. Theta is an element of minus 180 to 90. So let's have Calexis and Genya doing this for us. So it looks like a pretty innocent sum, but it's not really. And the problem is, if you didn't have this 2 here, it would be very easy. Okay, well, because you'd have sine is equal to sine of something else, and you can just drop, okay, the signs and they say blah blah blah. Okay, but this 2 means I can't do that in front. So the only option left is to use the compound angle formula, which says that sine of A plus B is equal to what, Calexis? My favorite name, that Calexis. Lovely name. Sine A cos B plus cos A sine B. Right? So if you go use that, Genya, what is sine theta plus 60 going to be? Genya is also a fine name, by the way. Sine theta plus 60 is going to become sine theta cos of 60 degrees, sine A cos B, plus cos theta. I would have said in this question no calculator, but let's just, might have said that, plus cos theta, where the hell are we? Okay, here, cos theta sine 60 degrees, and that's equal to 2 sine theta. I'm just using that rule over there and expanding the left hand side so that I end up with that. Right, and now, well, cos 60, you can go use your calculator. Cos of 60 degrees is a half, so you get a half, that's cos 60, sine theta. Sine of 60 degrees is root 3 over 2, so plus root 3 over 2 cos theta. That half is cos 60, and that sine 60 is root 3 over 2. Okay, and that's all equal to 2 sine theta. Now the angles are the same, so I can add like terms. And so what are you going to do next, Calexis? Indeed, you're going to take I'll get blah. You're going to take root 3 over 2 cos theta, leave that on that side, and we're going to move that across. So I'm going to have 2 sine theta minus a half sine theta, and those are like terms. So I get, therefore, root 3 over 2 cos theta is equal to, well, this is 4 over 2 minus 1 over 2, Genya, is, yes, 3 over 2 sine theta. So now fractions suck, so multiply both sides by 2, and I get, therefore, cos theta, blah, therefore root 3 cos theta is equal to 3 sine theta. So Calexis, what are you going to do now? Good girl, you are going to divide it by cos theta, and if you divide both sides by cos theta, what do you get? You get root 3 is equal to 3 tan theta. So root 3 over 3, I'm going around in circles, I do apologize. Okay, so root 3 over 3, I'll go here still. Root 3 over 3 is equal to tan theta. And Genya, if you use that magic instrument called the calculator, it says to you that you'll get an answer of 30 degrees. So I'm going here. Okay, so theta is equal to 30 degrees. It's tan, so what I do, good girl, you add K180. But then they said, bloop, they only want the answers between negative 180 and 90. So for our solution, okay, we're going to have, what's going to work? We're going to have a list of theta is equal to. Well, 30 works tremendously well because it's in that interval. If I add 180, it will be 210, which is too big. But 30 minus 180 is negative 150. Okay, and so I get 30 negative 150. Right. And because of your fine work, Calexis and Genya, whatever subject you have after this, just give it a skip. You've done your bit for the day. Okay, that, I think, ladies and germs, was page 4 of this lesson. Tremendous, tremendous stuff. Right, how's it, Owens? Right, we're going to do question F. F stands for frickin' amazing because this sum is awesome. It combines all the things that we need. So we're going to have a couple of Owens doing the sum. Let's have Rowan, and Deborah. Rowan and Deborah we can do this sum with us. So the first thing, Rowan is what? Yes. Rowan is indeed correct because she is tuning me. She's tuning me. Go do that. That's square. Just to be safe, put it over there. Okay? Then Deborah says to me, well, you've got a reduction formula here. Okay? An angle minus 180. So the way I think about it is I gooi here and I say, there's my angle. Always treat my angle as acute. And if I'm minus 180, I end up in that quadrant over there. And what happens to sine in this quadrant? Well, if I think of my all students talk diagram, okay, then in this quadrant over here, sine is going to be negative. So I don't go taking out that negative nonsense that they do in the textbook. I just gooi it in. Okay, so it's going to become negative. Sine is negative, so it's going to be negative in that quadrant, sine 2x. So you just chuck it in there. Right. Now this tan squared 675. It doesn't say without a calculator. So you can just go and rewrite this. How? Rowan, what do we do? Good. You gooi that there, then you gooi that into your calculator. Tan 675. Square it, go do that, and you'll see it spits out a value of 1, which means we probably could have done it pretty easily without a calculator. Right, now over here, what are we going to get? We get what? What do we get? Well, if I square that, anything becomes positive, so it becomes 4 cos squared. Cos of negative x is the same thing as cos x, so I get 4 cos squared x plus what? Yeah, boy, sine 2x is equal to 1. How lucky is the sum? Right. So now what? Okay, well, we've got a trig equation. Okay, and at the moment, sine 2x. Okay, well, let's get rid of that guy. Okay, and I've got 4 cos squared x. Deborah, what's that going to become? Yes, fantastic. 2 sine x cos x minus 1, so it's a quadratic, let's get everything to one side, is equal to 0. Now we have mentioned before what? We have mentioned before that if you have sine x cos x and a cos squared and a 1, okay, this whole scenario here is the only time we're going to replace 1 with yes, Deborah, sine squared x plus cos squared x. So I get 4 cos squared x. That sine x cos x is equal, and it often means that one has to change. Why do we change it? So that we can factorize the thing. Everything we see we want to factorize. Right, 4 cos squared x plus 2 sine x cos x minus 1 is the same thing as I'm replacing 1 with sine squared x plus cos squared x, just so by a mooi. Okay, done with your add like terms. So 4 squared x, that minus goes throughout the bracket. 4 squared x minus cos squared x is going to be 3 cos squared x plus, leave this in the middle circle, 2 sine x cos x, and then we've got minus sine squared x is equal to 0. And this is still pretty difficult. So what do? Deborah, yes, you got to decide, and you say, well, let cos x be a and sine x be b. So I've got 3a squared plus 2ab minus b squared. Could we factorize that guy? Well, if we go 3a, a, b, and I want it to be a plus, so that's going to be plus and then minus, and I get 3a squared plus 3ab, well, plus 3ab minus ab is plus 2ab minus b squared. So that works. So it's going to be, if I use that logic, I get, therefore, this is a moeder hard sum, 3 cos x minus sine x, 3 cos x minus sine x, multiplication by, a is cos x, following that pattern, cos x plus sine x, and we know that's 0. Check it if you want. You get 3 cos squared x plus 3 cos x sine x minus sine x cos x is 2 sine x. It is lovely and correct. So you've got two things equal to naught. So two things times together equal to naught. I can say 3 cos x minus sin x is naught. Or cos x plus sin x is equal to naught. So I end up with 3 cos x is equal to sin x over here. Let's solve them separately. Divide both sides by cos x, and I'll get 3 is equal to tan x. Hopefully you're comfortable with that now. And over here I get cos x is equal to negative sin x. Divide both sides by cos x, negative cos x, let's make it. And if I divide both sides by negative cos x, I'll get negative 1 is equal to tan x. So here you don't need a calculator, you just throw it in there, and Deborah, what do you get? You get x is negative 45 plus k 180. I don't think that. Oh wait, pause. In the question it said tan x. The question says, I forgot to write it down. You should have spotted it in your textbook and yelled at me. Tan x has to be greater than 0, so therefore here your tan x is negative 1. That's not applicable. Well spotted, Deborah. And Rowan, what's x going to be? Tan to the negative 1 of 3. Good girl, you get 71,57 plus k 180. The k is an element of integers. Okay. Isn't that pretty? Isn't that amazing? And that is the end of the lesson. Okay, you have some homework to do. Check your notes, but it's basically some of that rest of that exercise. If you've got some time, give it a go. It's been an absolute pleasure being in your company. Farewell.